This is the third segment of the lecture on fate and transport on the mobile source air toxic risk assessment ME 760 at the University of Waterloo. We're going to address the intake and ingestion rates in this third segment of the lecture. Inhalation is the direct impact. When we say we have a multi-pathway, we mean we have indirect pathways to hit the human body in addition to the direct pathway, which is direct inhalation. Once we have the emissions of the chemicals, we have vapor phase, particle and particle bound phase. These have two different mechanisms to hit the lungs where we will absorb some of those chemicals. Ingestion of produce. We already saw how to account for the media concentration for produce. And as a reminder, produce would be lettuce, tomatoes, cucumbers, things you grow at home. In the example here, carrots. We will ingest and we need to see how much we ingest and how much we will absorb of the total that is present in the produced tissue. Ingestion of fish, we know how to compute fish concentration. We ingest and we are exposed to the contaminants inside the fish. Ingestion of beef, milk, chicken and eggs. Again, we know how to compute all the concentration of the chicken and the egg. We saw even the equation. And we ingest the eggs, we get contaminated. So it would be a pathway, for example, for dioxin and furans. You can get high contamination because if you breathe, the concentration is very small, but it accumulates. So a good example that direct inhalation would be about up to 1,000 times less impact on the human than through indirect pathways, meaning through ingestion in this case. We know how to do the concentration on water. There will be benthic burial, remember, volatilization. Total water concentration, it will have concentration on the dissolved phase and the phase where the chemicals will sorb to suspended solids. We assume that humans will filter the water and therefore we will drink only the dissolved phase concentration in water. And now to close, this is how we compute the ingestion rate, the concentration on the tissue, the consumption rate. This is the exposure frequency. We need that because we have the averaging time dividing here, exposure duration, and the body weight. So we do it per kilogram of individual. The individual weighs 130 kilograms. We will divide by 130 kilograms. The individual weighs 70 kilograms. We divide by 70. We get it per kilogram of body weight. If you have any questions, please feel free to email me.